Our final speaker for DevOps Days is Paul Grizzaffi, who is a principal automation architect at Magentic. Yes. Hey, now, he said that recently, I guess, is it NDA on who the other company was? Yeah. You were working with Magnetic, and you were Magentic, and it caused for the spell checker just went crazy on it, right? Yeah, so caused a lot of confusion. But he's going to talk to us. His title is I'm Hunting Sasquatch, Finding Intermittent Issues Using Periodic Automation. Let's give a hand to Paul.
Hi, everybody. I know I'm all standing between you and lunch, so I'll get right to this. So just quickly about me, you got a little of the background already, but I do like to consider myself and my teams to be software pediatricians. Many of us have heard the old adage that the software developers are the ones who have the baby, and the testers are the ones that come in and say your baby's ugly. Okay, good, you laughed at the right point. You're not too hungry yet. So what I like to think of is we're the ones that come in and help this newborn, this fledgling software to grow up healthy, mature, something that we can deliver to our clients, to our users, and they make revenue, we make revenue, the wheels keep going around. If you're interested in contacting me outside of this particular forum, I've got my contact info up there and also my blog at the bottom. So the title is about Sasquatch. So what is Sasquatch? If you Google Sasquatch and go to Wikipedia, basically it's going to tell you it's a Bigfoot, the ape-like creature that lives in the Pacific Northwest of the U.S. But in our world, we have a different type of Sasquatch. And it's that error, that issue, that thing that pops up whenever you're not looking for it. We also have another thing we call this, and it's that issue that the developers never believe actually exists because they can't reproduce it. And as much fun as it would be, we're not going to talk about the first bullet today. But to set the stage for the rest of the talk and the experience report we're going to give here, I'll talk a little about integration hell, back how things used to be, and with some companies perhaps still are. So imagine, if you will, developers A and B are developing on their own branches, their own feature branches, and then they touch some common code. And then over time, they're touching more and more and more of this common code. So it diverges. It becomes more and more different between the two branches. And then eventually they have to merge the code together back into some other branch or the trunk of the master or whatever vocabulary it is you use. And then we have merge issues, right? We start testing, we have merge issues. Then we find some functional issues, and we fix them, and then we repeat, and then more merge issues, all right? Now imagine this across, say, 10 developers on 5 different branches. At that point, when you get all that finally merged and tested and all the onions unwrapped and all the Christmas tree lights are done, then you make the sweet mother of merge release. And we call it that because there's some people from that company here that I used to work at. We actually made a release called the Sweet Mother of Merge release. And we had t-shirts made, and on the back it said, Sweet Mother of Merge. And that one fortunately went pretty well, but it was because of all the time, all the effort, all the merging and testing that went in. So what will be our salvation from this? And most of you have already guessed where we're going with this, so I'm not going to belabor the point. But what if we could merge and integrate and test earlier? We could test earlier, we break the problem into smaller chunks, we find the issues earlier, and it can require less effort, be less costly to fix errors you find earlier. That's not always an absolute. Look into a book called The Leprechauns of Software Engineering by, I'm not exactly sure how to pronounce his name, but it's Laurent Bassavit. Very good book that sort of casts a new light on some of the common myths or non-myths that we think of with software development. So we hear this vote early and often back in the old Chicago days, but now it's really integrate early and often. Most of us know about this, right? This is continuous integration. We've heard about it from several speakers before. I'm not really going to belabor the point here because when Sherman says, Mr. Peabody, what is continuous integration? Clearly, we're at a DevOps conference and we don't really need to go into that very deeply here. But, again, to set the stage for the rest of the story, as we mature our continuous integration and the continuous delivery, deployment, whichever actual thing you're doing there, we start adding other stuff, the automated deploys, the automated functional tests or checks, and then we alert on any of these failures, and then we fix them, and hooray, we're ready to go. We're ready to push that button to push it out. Right? T-shirts for everyone. Sweet! Hopefully they don't say sweet mother of merge. But is this a recipe for disaster? Some of you have seen my shtick before, so this is a ticket for a ride on the fail boat. Not really. We're not going to fail if we do this. It's a little bit extreme. But there are some things that are difficult to catch if you're just doing test on event. So what types of things do I worry about here? I break these down into two different chunks. One is configuration type changes. The network changes out from under you, or the tool configuration changes out from under you. Hey, I changed some data here, or I got a new version of the tool, or it just got configured differently, so it behaves a little bit differently. And then your system under test, your product, the thing you're testing. Somebody went in and jacked with your data and you didn't know about it. Now some of these tests fail, right? Because not everybody's in a position to be able to do live data updates or interrogate the data ahead of time to know what the answer is going to be and then compute the answer. We're not all there yet, right? So we're going to have these types of issues. Fortunately, these issues, particularly the last two, we can handle a large amount of them by doing things like, hey, let's store all that configuration info in our code repository so that when we actually do a push and a deploy, we pull all that stuff out of there too, so it's versioned, it's the right version of things. What's much more interesting are what I call the intermittent issues, the ones that don't always happen every time. So what might be some causes of these? Maintenance issues. I worked at a company once where every day, about 4 o'clock in the afternoon, the system would crawl and some of the tests would intermittently fail. And couldn't figure it out, and then it kind of turned out it was this database process going on in the background that nobody knew about or nobody remembered. There's also the quirky test environment. Who has a really good test environment that always works the same way? Nobody? Wow, okay, so this one hits home. I worked at a company once where I was looking at some of the automated scripts they'd written before I got there, and they said, you get to this point, you'd hit F5. F5, this is a browser-based test. Why are you doing a refresh here? Oh, sometimes the product goes unavailable. What do you mean the product goes unavailable? Well, no, the web page says product unavailable. Try again. So we hit F5, and we continue. After I picked myself up off the ground, I said, well, has anybody reported this? Yeah, but this doesn't happen in production. Yeah, okay, you're chuckling. That's what I said. I said, does it not happen in production, or is nobody reporting it because F5 is easy to hit? Nobody could give me an answer to that. They weren't going to fix the test environment. But these can cause intermittent issues. Don't automate around them. Make a big deal out of it. But the ones we're going to talk about today are race conditions. Who knows what a race condition is? Okay, a couple of people. So a race condition is a condition in the software that you're writing where events, one or more events, can come in any order, non-deterministic order, just because of the nature you're dealing with interdependent but dispersed entities in your system. Huh? So let's go to a simple example. I started out my career in telecom, so I thought I would go with an old school telecom example. So when you make a phone call, somebody's a caller, the one who dials, and somebody's the callee, the one who answers the phone. So if your telecommunications network is working as it shouldn't care who hangs up first. If the person making the call hangs up first, then the far side goes, hello, 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 and the network is going to clean up some or all of those resources associated with that phone call. Vice versa, if the callee, yeah, I don't want to talk to you, who is this? Wrong number, click. Then the system has to clean up the originator side. That's in a good network. That's in one that's working. Now we have one that's a little more shifty, one that's not behaving correctly, and it's got an assumption built in. It doesn't handle the race. So it's assuming that the caller always drops first. So when the caller drops first, everything's cool. We clean up. But when the callee drops first, that's when our Sasquatch shows up. That's when we get that intermittent failure to say, hey, this should have worked. It's worked all the other times. When it was a different case, we just missed it. But we've only got 2 cases. how would we miss this in our functional test, right? This guy hangs up, and then this woman hangs up, and then we're good, right? Well, what about in this system? Where might we find race conditions here? Where might those Sasquatches appear? And what about in this system? Where might these interdependencies, timing issues, kind of pop up? I'm not even sure what that is. I think it's a circuit board diagram or something. But still, interdependencies are going to be in most places. And if you think about most of the world that we live in right now, most of us are working directly or indirectly with some sort of web technology, right? So we've got websites. So we're talking to multiple servers and multiple things all at the, quote, same time. Lots of places for Sasquatch to be introduced. So if we've got these cases, these potentially innumerable cases, why is it so difficult to do this? Well, basically because we're human, right? We're flawed creatures. We make mistakes. We get tired. Tedious things are just, we just start making mistakes after you enumerate. But we have computers. Computers can do all of this for us, right? They can enumerate all the cases, all the possible permutations or combinations, whichever ones you're interested in there. And then we can run it in the cloud, right? Infinite computing power if we have enough cache. Most of us don't have enough cache, and most of us don't have enough people to vet those results, because you're not going to get 100% green all the time. And we'll talk a little about green here in a second. And third-party interaction can be unpredictable. Your website, you're working with a bank. Let's say you're an e-com website. You're working with a bank. You're working with PayPal. You've got analytics from Google and whoever else. And then you've got your other website partner that you're working with. And all these things can interact, and they can come in different order, because today PayPal is a little slower or a little faster than it was when you tested it. So there are things that are out of our control that are difficult at the system level to do accurate testing on, or to do interesting enough testing on. We can do lots and lots of stuff at unit test. Absolutely. Big fan of unit test. But there are things that you just can't model at that level, because there's a level of unpredictability that is hard for us to know ahead of time. So what do we do about this? Is this the end of the world? Not really. So my first advice on this is keep doing what you're doing. On every event, build, deploy, whatever it is, run your scripts. There's value there. You're probably finding, if you're doing that today, you're probably finding some problems. Good. If you're not finding problems, it just helps you go faster. Yep, didn't find a problem, didn't find a problem, didn't find a problem. But supplement it with what I call periodic automation. And periodic automation is really kind of a fancy term for periodically rerun the scripts, or a subset of them, an interesting subset of them, not on an event boundary, perhaps on a time boundary, on some other type of non-event that says, we've got some idle cycles in our build world here. Let's go ahead and kick that off. Or, hey, we do have a bunch of cache. We have a separate environment that we're going to spin up, and we're going to run this stuff just every 20 minutes, 30 minutes, hour, whatever it is that you can tolerate. Because what it's going to do, it's going to increase the chances of you finding something that is not related to new code, that's related to existing code that is intermittent. But into each life, some rain must fall. You have to investigate every sighting. So there can be some extra work, and we'll talk about the extra work here in a second as well. So you need a very good development and test partnership here. If we're a good, healthy, sort of agile environment, or we're in a good, healthy DevOps culture, that's already going to be there, right? That's not anything you have to go and invent and build a tiger team for. But if we're not there yet, if we're not in this world yet, and this is something we aspire to, you may have to say, we have this intermittent problem that is a big business problem. Let's put a team together to dogpile on this and work through every time we see these failures. So, a real case, something I actually lived through. There was an issue in one of the products that we had, and it was you would log in, and then you would buy something, and every now and then you would be treated as if you weren't logged in yet. It would make you log in again. So this gets reported back to the dev team. Developer says, found it, fixed it. I can't reproduce it. Works on my machine. But the periodic automation finds it. So clearly we know what the problem is here, right? The automation's broken. If that's only an automation problem, automation's broken. So then we go with the gnashing of teeth and the rending of cloth of the, no, it's not automation, it can't possibly be, we're driving a browser or we're driving an app, we can't do things you don't let us. No, 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 you've got the wrong version. No, wait, so-and-so did it over here in the browser. No, wait, so-and-so did it over here in the dev environment. Wait, that's the wrong, blah, blah, blah. Days, weeks go by. Surprise, it was not an automation issue. It was an unhandled race condition. So the periodic automation helped, right? It was looking for things at different times than when you would normally expect to change. But again, there's a downside. Because if you're running this stuff more often, it is extra work. And I put extra work in quotes because it's extra because you're not doing it now. But if you want to solve a particular intermittent issue that is, again, a big business problem or a sufficiently large business problem to incur some sort of opportunity cost to fix, then you have to do the extra work. So at that point, it's not extra. It's required work that is in addition to what you're doing now. So most of the effort comes from triage, right? I got a failure, I got to go look at it. Yep, same thing again, add some logging in or tweak some settings and see if it happens again. I'll talk about pushing the van back up the hill. I won't have time for that. We'll talk about that outside if you want to. Focus on the failures, obviously. Oh, failed again, do we have any new info? Failed again, do we have any new info? But look at the successes as well. Because as you change your logging, your configurations, your successes may still succeed, but they may behave slightly differently. So if you look at what your logs look like in a success case versus what your logs look like in the new failure case with the new logging or the new telemetry or whatever you've put in there, if you look at these things, you might get a clue to, ooh, that happened here and it didn't happen in the failure. Let's start our investigation at that point, or that triggers the brain to say, I know where it is in the code, let's start digging there. And time is of the essence, so you kind of have to drop what you're doing and go look at this, because we are living in a world of in-betweens. We're in between code check-ins and in between this intermittent run or this periodic run versus this periodic run. So you got to kind of get on it, otherwise you may lose some valuable data because a code push might have gone in, which changes the state of where you are, which may mask the intermittent issue, which may make it less frequent, so it's even harder to catch. And if you don't have that good developer-test partnership, one of the results of failure fatigue here can be trust issues. Raise your hand if you've ever said, we only see this with automation. Yep. And I'm raising my hand because I've said or done or heard all of these things. Did you reproduce this manually? Yeah. Oh, that scenario fails sometime, just ignore it. Yeah, ooh, more. And then my favorite, run it again. If it passes, we're good. Yeah, there we go. That's the most common one, right? That's the most common one. And what happens when we start doing that, particularly the last one, is we get desensitized to the problem. Much like back in the 80s, I guess it was, when some of the groups were concerned that violence in cartoons was going to desensitize our kids to violence. I don't know, maybe it did, maybe it didn't, but that's sort of the take on here while the kids are watching TV, which could have easily been me. I spent a lot of time watching Looney Tunes, clearly. So are the trust issues that bad? And they can be. They really can be, because what happens is if you don't trust your system, you don't trust your information coming back, you're less likely to review the results. That's that test case again. It failed again. I don't have time to go look at it right now. You're less likely to investigate or report those failures. We'll wait till next time and see if it comes again, see if it happens again. And you're less likely to find these types of intermittent issues, but also, when you get sort of desensitized, you may be missing or late to the party on other issues. Because if that test, that one that always fails, that's reproducing this intermittent issue, if it fails at step 20 every time, but this time it failed at step 5, perhaps that's a different issue. Perhaps it's a different intermittent issue, perhaps it's a different consistent issue. You will miss that if you skip a turn looking at the results. So how do we keep up our strength? Well, one of the things you can do is really just alert the usual suspects and keep noise to a minimum. Okay, I changed the wording on that. So keep the noise to a minimum. Only alert the usual suspects. I worked with a really talented, actually, he was a really talented developer who decided he wanted to be a configuration engineer for the team as well. And what he did was, we work in the C++ environment, so doing a build on every check-in, it wasn't going to work. It was going to take too long. We didn't have the horsepower to do like big distributed builds and stuff like that. So he would check in, I think it was like every 30 minutes or 20 minutes or so. Everybody that had checked in, all the code would get compiled, but you would only get alerted on a build failure if you had been in the last check-in since a good check-in. So instead of the team of 20 or 25, everybody getting blasted with an email and everybody going, it's probably not me. You knew it could be you because there were only 2 people, or sometimes 1 person, that checked in code since the last good build. So that eliminated some of the noise. It made you more attuned to the issues, and you didn't get desensitized to them the same way. Most of us, or many of us, live in the world of reports that are non-abrasive but prominent. We have a big TV screen, and all our Jenkins or our Team City, it's red and it's green, and our build is broken or not. One of my favorite ones is the lava lamps. Anybody using lava lamps here? The lava lamps are great because the longer the lava lamp is on, the hotter the lava gets, the more it moves. So when that red one comes on, lava's really still, but you know, hey, we have a problem. The longer the build is broken, the more that lava starts moving. So that when you see, hey, that lava's really moving, it's been broken several minutes, tens of minutes, it just kind of depends on what kind of lava lamp you have. And you can find all kind of interesting stuff out there, like Nerf darts that'll aim at whoever the perpetrator is, and those work or they don't work, and I do not condone that. There's eye protection, and Magenic would be upset if I said you should do that. Better log and error messaging, particularly from your automated tests. We do a poor job on average of logging from automated tests. And it's very, very developer-centric a lot of times. We just take the error that the tool gives us back, and the tool's dealing with things typically at a sort of a developer level. You're going to get ID mismatches and things I couldn't find and stuff like that, where if you put a little context around it, if you put a little domain-specific language or domain-specific terminology, then instead of looking at web ID, blah, 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 it might say, I couldn't find the login link when I clicked it, when I tried to click it. More people can participate in this debugging and triage process, and it often is faster because then you don't have to go and look up IDs and things like that. The most novel approach to these types of problems are fixing, right? So if you've got a problem with your tool, fix it, replace it, upgrade it, figure out a workaround, sort it out. Same with the scripts. You have a script that is not behaving consistently because there's something wrong in the script, fix the script. And the most novel one is, hey, fix the product. There's a problem here. Let's dogpile on this. Let's fix this product and move on to the next thing. Or, and we'll talk about the value proposition on the next slide, but maybe we're only going to test what we're going to fix. We're not going to test things we're not going to fix. So how many people identify themselves as testers or test-related people here? Okay, a few. Don't throw anything at me yet. Bear with me for a second. So wait a minute. What do you mean we're going to stop testing? We're not going to test everything? Well, follow me. Fixing issues requires effort, right? We've got to find them. Then the developers have to debug them. Then the testing has to happen. And there's effort that goes into here. So there's an opportunity cost to resolving issues. Opportunity cost being the cost in some business sense of you doing task A, not doing task B because you're doing task A. There may be a real or sort of funny money loss along there, so that has to be figured out in a business sense. So the business may not want to fix. Yes, that's a problem. We get it. It's a problem here, but if we don't make this deadline, we're going to lose a $10 million deal, right? We're going to defer this. We're going to fix it, but after our deadline in 6 weeks. So what do you do with this failing test? What do you do with this failing script that happens every time or almost every time? Well, you keep running it, it's going to lead to constant or intermittent failures. So then you're going to lead to more triage effort or desensitization and more failure fatigue. So there are ways to kind of mitigate this. You could remove the script, right? Certainly that will stop the failure. But you could be a little more ingenious and say, well, if the business says this is okay for now, then the product's behaving the right way for now. Let's change the test script to check for the wrong thing. No groans, no tomatoes. Okay, good. Because what you can do is make it now, right? So you do get your greens. You understand the behavior I'm expecting is what I'm getting for now. But then you need to put a task in your work system, under your story, or whatever it is you're doing, to say, go and fix that, along with when the bug is fixed, go ahead and fix that as well. And if you really want to gild the lily, you can make it actually fail when the right answer comes in. So then you'll know, hey, wait, somebody fixed some code and we didn't fix this test. Or, hey, you know what? It's supposed to fail every time. Now it's only failing sometimes. We have a new intermittent issue. Now, I'd like you to think that I'm a genius. I came up with this on my own. But I sort of backed into figuring all this out. I'm lazy. I like to think the good kind. Don't ask my wife. I needed a CI-like environment, but the company at the time, it wasn't there. The team was actively working on it. They were getting it built up. They were proving it out, but it wasn't ready. But I needed to run some tests, some scripts periodically, just to show, hey, you know what, nothing got broken since the last time code was checked in. So I just wrote a little batch file that every 30 minutes would run the scripts. And what I found was that it was good at finding Sasquatch, and I just realized, you know what, the more we look, the more we're going to find it. So these sort of serendipitous moments are always kind of cool to say, look, we're adding this type of value in here. Really at the core of what we're talking about here is something called high-volume automated testing, or HIVAT. So this is not load, capacity, traffic type testing. This is a different type of testing. It's generally classified as a set of testing techniques that allow testers to run arbitrarily many tests and evaluate the results. There are a lot of different facets to this. Unfortunately, we don't have time to go in very deep into them, but there's some interesting facets for tools that can help us find actual issues, but they have to run outside of continuous integration because the nature of it being a high-volume automated test means it tends to run long in most cases. Far longer than you're going to want to wait to hear that your check-in and your build and deploy was good. So the interesting facets of HIVAT for the particular example I'm going to give you here is long-running tests. So again, not really a good candidate for running in a CI environment. Randomness. Who does randomization in their testing? Yeah. So random is cool because it'll catch things that are valid but not intuitive because you kind of randomly generated some of this data, some of this input. The important part here is to track what you used, because if you have to go back and reproduce an issue, you want to know what exact values were shoved into your system when the check didn't work. And human investigation of results. The other reason it doesn't really work in a continuous integration environment, because this is about turning cranks. This is not about yes, no, pass, fail, red, green. This is humans are not suited for turning cranks. Machines are. Humans are good at looking at results, lateral thinking, creative thinking, figure out how do we create these tests, what do we do with the results. So at two different companies I've worked at, we created something called Scud. And if you're not familiar with the Scud missile, it's pretty much infamous for the fact that its guidance system was faulty. And every now and then when you would shoot it off, it would go to some random place. So we kind of took a play on that. One of my former leaders was sort of a weapons guy, so we did a lot of weapons analogies. But we did two different implementations. One was at GameStop when I worked there, and it was a random link clicker, and it would just go through the site and randomly click links, looking for things that didn't seem right. What do you mean? What do you mean? Anybody familiar with, oh, I'm almost running out of time, we'll skip that, but basically it's looking for things that don't seem right. It didn't know what the right answer was supposed to be, but it knew what the wrong answer was. A 404, a 500, a server crash, ODBC error, anything like that, and you'll have some specific ones for your environment as well. Your own 404 pages or some other things that you're going to accidentally get displayed up. And it reports on these things. It reports on these things that don't seem right, and it'll take a snapshot. If you're going through a GUI, it'll take a snapshot and leave a trail of breadcrumbs on how you got there. And the testers audit the results. So here's a stack of stuff that didn't look right. I don't know if it's right or not, but I know it was in the parameters you gave me and the heuristics you gave me, it didn't fit. So why don't you have a look at this? And again, it takes a long time, so it doesn't really lend itself to pass-fail. So there's a DevOps conference. Where's the DevOps part? It's all of it, right? This is all collaboration to solve problems, dogpile on problems, get these things fixed, look at tools, even if it's alternate tooling than what we typically use, and work in these corner cases. Because if you look at your automated, your DevOps world, automation's a common thing we talk about here. Automated deployments, automated functional tests. It's even in the CAMs, right? So automation's in there. The big A automation, automating those things, those tasks, those items that should be automated. Few teams take advantage of these corner cases, repurposing tools, off-label tool use to help you get things done. So I'm over time. I'm going to get the takeaways and we get to eat. So some issues are intermittent. In our world today, with the distributed systems we have and with our computing capacity that we have, there will just be some intermittent problems. It's just going to be that way. Keep doing what you're doing. Run on deploy. Consider adding periodic automation as much as you can tolerate. Look at your results, pass and fail, and beware failure fatigue, because the failure fatigue will kill your initiative. And that's all I have. Thank you.